Hello, class. I've got a couple of demonstrations that I want to do. We'll be talking about them in lecture in just a bit. The first reaction I want to do is the reaction of magnesium metal. So I've got a piece of metal in my hand. You're simply going to have to trust me that it is magnesium. I don't know how this next part is going to show up, but I think if I hold that right next to the camera, you can see the end is shiny because I have sanded on that. And if I come down a little bit farther down, you see it's black. That is because the outside of this piece of magnesium metal had corroded to give magnesium oxide. But I wanted to sand away that magnesium oxide to give a nice fresh strip on there. Now, in a moment, I am going to ignite this. Note that this piece of magnesium I weighed out and is approximately 1.00 grams of magnesium. We'll use that in a minute. It is the case that magnesium metal is actually a flammable metal. It's a little bit unusual as many metals simply will not ignite. So I'm holding it here with a pair of wire cutters. I've got an assistant here that's going to take and help me light this. So let me get this positioned and I'll hold it. Pardon me while I adjust a couple things real quick. Okay, I think there we go. We've got that as well as we're going to position it. So put the flame right there on the end of it. There we go. So I don't know, again, how, there you go. You ought to be able to see that is burning very, very bright, perhaps seeing a little bit of soot coming off. And so this is the reaction of magnesium metal. Pardon me, it's blowing in my direction. There we go. We'll get it going in the other direction. Oops, it went out. Let's go ahead and light that one more time. See if we can get it lit again. Maybe not. What has happened is it only burned to the extent that it got down to where I hadn't sanded away the outside. So this simply may not relight. Okay, well, we're going to have to call that one good. I'll do some of the calculations in a bit. So we're going to set that one aside. Now let's go over the next demonstration. Perhaps you've seen this demonstrated before. This is hydrogen peroxide. Note that it is 30% in water. The hydrogen peroxide that you may have in your medicine cabinet or underneath the sink in your bathroom, if you do have it, is 3% in water. So it's the same chemical, simply different concentration. Hydrogen peroxide has the molecular formula of H2O2. I am going to react this in a moment, but there are a couple of things that I want to do. Here's the container that I'm going to put it in. Excuse me for a moment. There we go. And in a minute, you're going to see why. I'm going to put a little bit of detergent in here. This is just, some laundry, or not laundry, some dishwashing detergent. So I got that. A little bit more is not going to hurt matters. So I've got a little bit of detergent in there. And we know, amongst other things, that detergent makes suds. All right, I'm going to take the hydrogen peroxide into the container. Don't have a lot of it right now, but that looks to be just about the right amount. So I'll swirl that to get it reasonably mixed. So I've got that swirling. You can see it's taken on a slightly green tint because that was the color of the detergent. Now I got to find a place to set this down where we can see it, where it's not going to get my computer messed up. I think. There we go. Right about there. Off screen for a moment. This next material I've got, you can see I've written a little label on there, saturated potassium iodide. So, and by the way, I had measured this out before. This is about 200 milliliters of hydrogen peroxide 30%. So I add the potassium iodide in there, and here we go on 3. 1, 2, 3. And perhaps if you're a fan of the Big Bang Theory, you've seen this there. It has been demonstrated in a number of different places and contexts. Sometimes this is referred to as elephant toothpaste demonstration. Okay, so I'm going to stop the video here in just a moment, and we will discuss these reactions in class.